All right. Hey, everyone. Today I'm going to give you a somewhat incomplete guide through the realm that is GHC Haskell language extensions. It's meant to be a sort of digest. Some pieces will be missing, but I hope to kind of at least show you the intuition behind some of the major language extensions and basically point out a few of them that are worth looking into a little bit more. So, this is me. You can find me on IRC, GitHub, GitLab. I have 2 blogs now, one on game development and one on just general things.
Game development?
Yeah. Recent. Yeah.
Interesting. I'll check that out.
Yeah. I'm trying to work up a kind of 2D game engine as a side project whenever time allows, and it's been interesting messing around with things like GLFWB, and bleh, there's a few issues, but yeah. All right, so kind of the overview of this whole presentation is extensions as a Haskell user, how do you interact with the system, extension categories broadly, kind of breaking things down into little what they change in the language. What I won't cover, Haskell 2010 in 5 minutes, some small, easy, and quick extensions, and then we're going to dive into GADTs, existential quantification, generalized new type deriving, empty data declarations, and scope type variables. And the resources, that's a lie. I didn't actually get to fill in resources, so I'll send that along later. How do you enable extensions? Like, how do you go about doing this? So let's say we've got some like really simple hello world-ish file. Bam, now we've got overloaded strings. Now we've got GADTs. Not that it's really doing anything with this particular example, but that is how you enable language extensions. You could, that's the canonical way to do it. You could also put it in a Cabal file under an extensions field. Usually I've seen no implicit prelude here. You could also specify them in the command line by passing in -x options. And one I left off of here is in GHCI, you can do :set space -x as if you were passing it via the command line.
You can tab complete.
Oh yeah, the tab completion is sweet. Yes, definitely do that. Extensions, categories, not in a mathematical sense, though they could just be functors between all the Haskell categories, perhaps. So I categorize them by what part of the language they change. We have, so with one caveat, we deviate a little from the way the GHC user guide categorizes things. So we've got syntactic extensions. They mostly add sugar. They maintain the semantics for the most part. So like record sugar, new literals, more ways to pattern match. You've got data construction extensions, more things to it increases your capability of expressing and modeling things when you're specifying your data types. Derivation extensions, just kind of adding more magic to the derivation backend. Type classes, generic programming, evaluation modifiers, runtime system additions, signatures and inference, and an error. Also dependent types. Dependent types would have saved us there, but we don't have them.
Are you going to cover like from the table from all of these categories?
No, definitely much less.
Which ones are you going to hit? Which ones? He just said.
Here it comes.
Oh, okay, sorry.
So several small, simple, sugary extensions, and then specifically these big 5. Haskell 2010. What does it look like? I didn't actually include any slides on this part, so I skimped on it. So the 5 minutes is going to be really easy to keep as a promise. You have record types, you have sum types, product types, you have pattern matching. Oh, I guess it's fair to ask, who here hasn't seen Haskell before? Okay, makes it a little easier. Haskell 2010 doesn't have GADTs. That's a good start. You don't have view patterns. You don't have tuple sections.
Are these things it's throwing out from 98?
No, those are things that are added in as new extensions. Yeah, I actually don't know just how much 12 years of Haskell between 98 and 2010 actually adds. I didn't take the time to look back at the 98 standard.
It's very little. There's like 1 or 2 very minor extensions that they added in 2010 as a default. Other than that, it was a very conservative change.
That's good, because I struggle to think about what those additions are too.
I think they tried to add like non-controversial stuff.
That's basically it. Yeah.
Because we've seen what happens.
Oh.
Nothing.
Oh, and they took.
I don't know what you're talking about.
Everything's fine now.
They took away n plus.
Yes.
They took away n plus k or whatever they called that.
N plus K patterns.
Yeah.
Oh yeah.
Oh, kind of a fun fact on things that are being taken away. I was reading in the GHC 7.10 guide, under the language extension that corresponds to being able to put a type class constraint when you're declaring a data type. So data set A, that all manner of it is bound by ORD and EC, which is considered an anti-pattern. I saw the GHC user guide specifically say this is being considered for deprecation and removal. So you can't do that anymore.
To what?
You can't type class constrained data declarations.
Yeah.
Oh,
Yeah.
You shouldn't. So that's fine. Edward puts a good argument forward for why you shouldn't in type classes versus the world. The YouTube video's up. You can just search for that.
That was a good talk.
Yeah.
2 hours though.
Yeah.
Well,
It's an open tab.
I can't watch videos. That's the problem. It helps to double speed it in case you forget to double speed it. Like in case you forget, wait a second, that plugin or whatever will help me do that. Turning 2 hours into 1 hour is amazing.
Yeah, you can still understand what he...
Of course.
You sound like Alvin and the Chipmunks.
Edward already talks pretty quickly.
That's when it goes 3 times before.
Yeah.
He's him at 2x. That's a little too Alvin for me.
All right. So that was Haskell 2010. So from there, we're going to build some intuition to see how the extensions change the language. These are Haskell 2010 examples. You can think of that as a typed hole, and we fill it in with a full Haskell program.
Is that a complete Haskell program?
It'll give an error with, I don't even know. That's a good test case for the typed holes extension. So simple extensions. These are ones that don't take all that much to understand. So I start with magic hash. The basic idea here, and it strictly is just this, is that it enables the use of the pound, the hash symbol as a suffix in the names of things. That's it. So why does it actually end up mattering? GHC primitives, all the unbox types, by convention, happen to use this naming scheme. So in order to access those in your programs, you'll need those this extension. And you can check out all the unbox types in ghc.exts. Binary literals coming in 7.10. Simply 0b and then your binary string pattern. And it's interpreted as from integer and that literal as an integer. So that would be like 2, from integer 2. Pattern guards. It's a generalization on guards. You allow pattern matching instead of just Boolean predicates. So here we have f applied to x and y. The first set is we peel out the maybe, we peel out the maybe. If they're both just values, then we return just x prime plus y prime. Otherwise, it's nothing. That can clean up a lot of like lookup patterns where you're seeking into an environment or something like that.
Top. I must be missing something. I apologize. Why I'm not seeing the new feature.
The comma between the two just.
Okay.
It's also the guard. Like, notice how they're not like, oh, this evaluates to a Boolean thing.
Mm-hmm.
Right? Because
Normally the part after the pipe has to be a Boolean valued expression.
Oh,
Yeah,
Gotcha. Okay.
it would have to be like if just x and is just y, do the thing.
Normally you'd have to do the pattern match and the pattern part. And the
No,
guard.
thank you for that. Thank you for that helps quite a bit. Yeah.
Cool.
So basically, it just stops the evaluation if one of the pattern matches fails?
Mm-hmm.
Okay.
Yeah, it'll go through each one, and it's a comma-separated list of patterns that you require, and it aborts on the first pattern match failure, proceeding to the next branch in line.
I'm going to ask naive questions because I haven't thought about this just yet.
Sure.
How different is this from just a normal case match?
Well, for the normal case match, we would have to do case x of thing, and then case y of thing.
That's true.
Yeah.
There's convenience here in addition to that.
Yep.
So in a way, this is almost like not necessarily like a better guard. It's almost like a better case match as well.
Well, I have a trick for the case matches. When I'm depending on the state of more than one variable,
Tuples.
yeah, I just tuple them.
I generally avoid this kind of sugar just because if it's in the body as a proper expression, I can refactor it easier.
Yeah, that's the same reason I just use case expression.
I
Yeah,
definitely
can't
don't
get
use
too
guard.
excited
I mostly
about
get
this.
the syntax example.
It's nice to have, but whenever stuff is lifted to the left side of the equals, like it just makes it gnarlier when I need to change it.
Yeah, I agree.
But I
Yeah.
understand what people want.
A lot of this is like it simplifies maybe early prototyping and thinking before you lift it into a better way to handle it.
Yeah.
Like you'll see later when I get to multi-if, the multi-way if.
Yeah.
I've got an example there that's kind of relevant to early design. So tuple sections, you get partial application over tuple construction. So you can do something like that. And equivalently in Haskell 2010, it would just be like you pass a lambda expression with an A, B, and C that fills in the places that would have been holes otherwise. So just kind of nifty. I haven't.
Does everyone see what's happening here?
Wait, why is it T1 instead of a num? Oh, num T1, sorry.
Yeah.
Yeah.
Yep.
The literals are polymorphic by default, so you don't know what concrete type they are until you get
Right,
enough
cares
information.
concrete, num's type class, okay.
Yeah.
Lambda case, if you're going to do shorthand kind of inline case expressions, you can just do /color case red, the red case and the green case. Otherwise, you would have to do it without the extension as /color case color of. So you can just kind of avoid needing to type out the rest of it.
Example shouldn't be /case.
Actually,
It might require /case. I'm not entirely sure.
sorry.
Yeah?
Sorry. Sorry, I'm interrupting you, but I actually had a question about the previous slide. I realized I did have a question.
Sure.
Yeah, so my point is this is a value, right?
Mm-hmm.
And so this is a type of a value, and it's interesting because it's a tuple, but it doesn't. It turns into a lambda. It turns into a lambda. Okay,
Sections.
sorry.
Yeah.
Okay, yeah.
It's like sections.
Value,
Yeah.
it's like a function that produces.
No, I'm with you, and I see it now.
It's so you don't have to worry about like the ordering and naming of the individual arguments. So if you're like filling in, yeah,
Definitely. No,
that's,
thank you. I didn't look at the type signature well enough. Got it.
All right, all good.
Oh, and the comment, which is very illustrative.
Yeah.
Thank you.
You're welcome. Okay, lambda case. So I need to look at the guide a little more closely here, but it may require /case instead of doing the whole color thing there. Yeah, good point, Serge. Multi-way if. So instead of doing if then else, if that's something that you're using in your Haskell programs, you can just kind of combine the if syntax with the guard syntax, and you end up with something like this. So like if HP percentage is greater than 75, healthy, standing, faltering, running, and then nope. So that might be like an early approach to lifting game state values into your algebras.
this actually seems really useful to me because one of
Yeah.
the problems with case expressions when you do the tupling is like some elements of the tuple won't be relevant in every case.
Mm-hmm.
And with this, you're just referring to whatever's in the lexical scope, and you don't have to bind them up into like one big tuple. So this actually seems like a really nice alternative to that.
Yeah,
so
I
I'll
like
probably
this
end up
one.
using this one.
I like
Yeah.
this one.
They can be nested too.
Oh.
Yeah.
Well, but, I mean, yeah, since you're not doing pattern matching, you don't need
Yeah.
the
Yeah.
Mm-hmm.
That seems really nice.
Yeah.
Provided people don't use it and make partial functions out of, like the otherwise it's like really important when you start making these crazy nesting structures.
Yeah.
Yeah. You lose the inductive properties here, but in that case, you try to be complete about the domain that you're covering.
Yeah. No, it's just fancy if statements lead to people thinking they should write fancy if statements.
Mm-hmm.
That would spiral sometimes.
Next thing you know,
Yeah.
we're all homeless on the street.
That's what partial functions do.
software
children.
has never made a programmer go hungry.
All right, so now we get into some of the record stuff. Named field puns, they're kind of cute. So we've got a data type D with field A and B. The old way to handle this, you'd pattern match in this fashion: A equals A, B equals B, so that the A takes the value of whatever A is in D and so forth, and you just kind of do your thing. The new way, since they acknowledge that the old way is pretty much that's exactly what you want, you can just extract it by the names of the field accessors, and it'll do the right thing.
Hell yeah.
And possibly even better, on the next slide, record wildcards.
Oh yeah.
You just bring all the fields in for that data type in a scope by their accessor name. Just do the ... You can also like pull out a specific field with a given value and then do the ... so you can kind of mix it up with name field puns.
Haskell with.
Did you see the record wildcards where you return?
I think I saw it in Oliver's
Grab
post.
things and that's-
Well, it lets you
so
return like a
construct
new value of that type, but then it pulls what the new values are going to be from what's in scope.
Yeah, okay.
Yeah, so it goes both ways. Not only pull stuff into scope, but it also lets you selectively like reconstruct.
Right, so
Parts
if you're
of the-
creating a D, it'll pull the
Yeah,
A
yeah.
and B from the
Oh, so you-
So
lexical
it is,
scope.
yeah.
You're saying the constructor bracket notations, curly brace notation.
Well, so if you have record wildcards like this, and then you do something like, say you do like a let, and then whatever the field name is, you can do it so that you're returning a new instance of that value, and it's just going to do the return the new record with that one field being different, because you're not actually mutating. You're just
Right, but you're saying, I think I've seen that, but then if you basically had that ... notation as your return value, it would just suck in everything
yeah,
that was lexically
yeah, that's
matching.
exactly it. That's exactly it. Yeah. So the thing is that because of that, record wildcards does make certain people a little bit angry. So here's the thing: if you have like a product, like a like a business logic type thing, and it's like 50 fields, like I'm sympathetic, but at that point you have to like start. You should also just be decomposing things. But then if you start decomposing them by creating a hierarchy, then suddenly you need lenses, and that makes even more people angry. So it's like you can't win.
Take your pick.
Yeah, I can see this. You use this,
Especially if the
use this at the
categorization's
top
artificial.
and the bottom, and you just sort of explode it and then put it back together.
Yeah, yeah. I really like it. I just try not to use it like over much.
So I wouldn't mind, the records package, I forget the guy who wrote it.
Nikita?
Yeah,
Okay.
I wouldn't mind having these conversations in context of that library, like, kind of a follow-up, like later on or in the future. Because I think that there's conversations to say about records in a more like holistic sense.
There's a lot to be said about the record system.
What's that?
There's a lot to be said about the record system. It's such active development right now in that space. Like, it's not just Nikita's proposal, but there was someone else working on
Overloaded record fields,
Mhm.
Adam Gundry.
Actually, in terms of context, are these all under a named extension?
yes. Oops.
Yeah,
Um,
I think that this.
It's literally record wildcards.
Just
Okay, so
like
every
spaces.
page so far has been a separate extension.
Yeah.
Yeah.
Okay.
Yeah.
Yeah.
So you have to add a pragma for each one that you use in a file,
Yeah, I don't think.
because we're required to declare what
Or,
we're doing.
or if you're Stack Overflow doing it, the compiler usually tells you.
Yeah.
You need this.
Oh, yeah.
It'll just tell you, you just copy and paste. And then,
Should automate
in
that
fact,
process.
if you're using the Emacs
Go back
font,
and paste it into the file.
if you're using the latest version of Haskell mode for Emacs, it actually says, hey, you're trying to use a pragma. You hit Y to go ahead and add this to the top of your file. I'm like, back in Java.
Back in Word with Clippy.
It's Christopher Dunn. It's just like the way he directs the development.
It's nice.
It is.
All right.
It's
So.
like trying to use a controversial extension.
And then it automatically posts like a controversial blog on Reddit.
Tweets.
Yeah. You have an essentially quantified type variable. You sure you want to do that?
So here's one that comes into play when you start working with a lot of the other kind of advanced-ish extensions, explicit namespaces.
Oh, wow.
It allows you to disambiguate between what namespace a name is coming from. So valid options like prefixes here are pattern, family, and type. For example, like what we're importing here, we're importing a pattern F, type operator, ++, family Z, and then concat with, which just lives in the term namespace. So that's kind of the scope of all the things the Haskell language is doing right now.
Is this because you can have something of the same name in each of these types? Like you can have a family name this, you can have type name the same thing.
You're
a
not really
pattern name the same
supposed
thing.
to ordinarily. That's why you have to turn on pragma for type operators, because operators are supposed to be term level only. The reason you're required to turn on a pragma for type operators is because you've now blended the type and term levels syntactically, and it's confusing.
Yeah.
But for like pattern and family,
Well, I mean, yeah. So like type families obviously like add stuff into the type level, and then patterns are.
I feel as though I don't have enough context to understand this slide just yet.
have you seen pattern synonyms?
Maybe not well enough, right? Yeah.
So in Haskell 2010, there's 6 different places. I just got done writing this in the book. There's 6
Nice.
different places names can come from in Haskell 2010.
Yeah.
It can be a variable. It can be a data constructor.
Yeah.
It can be a type constructor.
Yeah.
Fuck, I'm gonna forget. It can be a module. It can be type constructor, module.
Type class.
Type class, yes, and then there's one more. What am I forgetting?
Type variable?
No.
Or is
Type
that-
variable. Yeah, type variable. Yeah, you've got it. Yeah, that's
Cool.
it. Exactly. Okay, so those are the 6 standard things, and then they break out into 3 basic subcategories.
Yeah.
Modules, although an ML user wouldn't want us to call them modules, call them namespaces, it doesn't matter. And then at the type level, you have the type class, type constructor, and type variable. And at the term level, you just have variable and constructor.
Okay.
Because there's actually like nothing else.
Okay.
Well, as you start turning stuff on, like this actually relatively clean delineation starts getting muddled a bit. Like with type operators, you've got pattern synonyms, which are kind of like this, like syntactic construct for. I think they're baked basically in F algebra, but like still it's like kind of Deus Ex Machina. And then so like type families like add a whole like type function basically to the type level space.
Gotcha.
And that concat with there just looks like a normal term.
Did you say type classes were in their own?
No, they're part of the type level.
They're part of that.
Yeah, they're just
So what this allows you to do is to very delicately pick out exactly the name that you wanted out of the module.
Yep.
Yeah, it's a way to
So it's
enforce
like-
intent. So like
Okay.
if you had like imagine for
Otherwise
example.
It might be
Full-
ambiguous otherwise, right?
It might be ambiguous otherwise. Okay, sure.
Well, shouldn't this have been on the export side in the first place?
Well,
That's not part of the export syntax.
Yeah.
Some people.
Yeah.
Well, normally syntactically, there's no ambiguity.
Well, you may want to export a pattern synonym and like a type family that have the same names. Like, what do you do there?
Well,
No, I'm not saying this is a good
I
like.
mean, right now, if you
practice.
put
I'm
the name in
saying,
the
like-
export, you get everything that could possibly match, right?
Well, the thing is, normally that's not true. Like, if it's lowercase, it has to be a term, and if it's uppercase, it has to be a modular
Okay.
type. Like, there's no real way to confuse those normally. And even with type operators, it's not really that confusing. It's just like, because there's no ambiguity. If you have a type operator and a term level operator, it's going to know which one you mean just based on whether you're using them in the type or term level, right? Because we have that clear delineation. This is one of the reasons why, like, people who think when we get dependent Haskell, it's going to be just like Idris. No, it's not. We can't just like smush these together. Like, there's still going to be this rift. And
Because I haven't pushed the envelope, but I definitely haven't encountered name ambiguity of this.
well, it's not really resolving. Okay, you're not fixing anything.
Yeah.
You're making an assertion for safety's sake. That's
Mhm.
all.
Okay, no, that's fine. I just because the likelihood of running into the ambiguity in the field may not be as likely, but you can still have this delicacy. But God,
I don't think you could get an ambiguity like in terms of imports or exports. It's just
Yeah, I know.
It's just to
Right.
assert like what you think you're getting. That's all.
Okay.
But it's a little bit more work after. I
Well,
just like.
people are already lazy about even qualifying their imports. Like this assumes you're dealing with somebody that even qualifies their imports.
I know. Let me start another
I mean-
Twitter war here.
At least by default, it's a
And
common
sense.
case, I guess, right? Like the functions, you don't have to put like little keyword prefix.
Yeah,
You
I try
don't.
to either use like a qualified keyword prefix or just call them out by name. The only time I don't is when I'm using like a whole framework. And it's just like
No, I mean, hell, maybe this is maybe this is a reasonable way to go. I mean, because the default doesn't require extra keyword, so maybe it's nice to say type if that's really what you mean.
It's a communication mechanism.
Yeah.
I'm kind of fond of it.
Okay, you sold me.
Right. Bang patterns. Lightweight strictness annotations. Preceding. Hey, I didn't finish something. Work in progress slides. Awesome.
That's what we know you mean.
That's what they look like down there. Those exclamation marks preceding the name and account ID field, we're saying that those have to be evaluated strictly. Some conventional wisdom here. Strict leaves, lazy spine. What that means is for the data types that are going to represent kind of your core business resources or objects, those are typically going to be mostly strict fields. But for your data structures like your finger trees and your hash maps and your lists, keep all of those lazy because you're not going to necessarily always access every part of the finger tree when you're using it. But of course, take that conventional wisdom with a grain of salt and profile everything if you have the resources to do so.
So this already existed for normal data structures and now it exists for records? Is that the new?
This has been around for a while.
Yeah, this is an older extension. You just have to enable it.
But I'm just saying that without an extension, you can do this with data constructors already, right?
I don't think
I
so.
No.
Oh, really?
Yeah.
Yeah, you had to make a constructor, and then you had to put the strictness in the custom constructor.
You have to do your own dollar bang.
Well, no, you're
No.
using Seek.
You have to make a smart
Yeah.
constructor, you're saying.
Mhm.
Oh.
You had to make a smart constructor and Seek everything yourself.
Yeah,
Okay.
this
Which is still tricky because like Seek is about interdependence, not like a fiat like lightning bolt comes down and forces your thumb type thing, which a lot of people don't appreciate. So your smart constructor itself is not going to force everything unless your chain of Seeks is hooked up to something that also gets forced. Because you're like forcing like this chain reaction in a graph reduction model. You can't just like come out of nowhere and do like bang, strict.
Yeah, it's push, not pull.
Right. So it has to be hooked up to some. It's kind of like the I/O thing where like you can't really have like an island of side effects. It has to somehow flow back to the main.
Yeah,
It's kind of the same idea.
that's actually a good topic too, because you and I were recently talking about like weekend normal form and
oh yeah.
Yeah, it's normal order. That's the reduction strategy. I also just got done writing about this. So, yeah.
I'm really gonna need to look at this chapter.
Nice.
No, not type classes. I was writing it for recursion and lists.
Okay, so let me ask you this. I'm going to back up because I like asking the basic questions. The bang operator, without any extensions, is allowed on functions in some place.
What?
No. The bang operator, this idea of an
No, it's not.
exclamation point,
Mm-mm.
right?
No, it's not.
It's not allowed anywhere
No.
without an extension.
That's right.
Right.
I didn't
It's
know.
for data constructors.
Okay.
This
well,
is so just
What
so you
about
can get an
bang patterns on
idea.
function arguments?
Huh?
How about bang
I
patterns?
think he's asking about the bang operator.
Oh, the
it's
bang.
not-
Oh,
it's
like
not
the
an operator,
array
it's a
package.
Syntax, a special
Oh, okay.
syntax.
No, there's
Yeah.
bang bang, but
Yeah.
single bang doesn't exist outside of this.
Okay, gotcha.
Isn't there f, like you're defining function f of a single variable x, can't you write f $x equals
I
whatever?
thought that there was a way to use the exclamation
I'm pretty sure
point.
that's a
No,
thing.
the dollar, yeah, the
Oh.
dollar bang.
So
No, I'm not talking about dollar bang.
Wait, what?
I'm talking about f space exclamation point x space equals and function body.
Yeah,
That's a thing.
that's the thing, isn't
I
it?
don't even know. Yeah.
That
no.
I'm pretty sure that requires bang patterns, and that is a strictness annotation.
Okay, but you're acknowledging that exists as
Yes,
a syntactic construct
it does.
in Haskell.
Yes.
Okay, that's,
No,
that's what he was
No,
asking.
it does, but I think everyone's saying that that's a bang pattern and it needs this extension.
Well, I think
Yes.
that's why it's called bang patterns.
Sure,
it's
sure,
actually
sure,
for that,
sure.
not
Okay,
even
no,
for the data
that's fine.
constructors.
I think what happened is I did a little too much reading, and when people write little code snippets, they don't always tell me what fragments they're using.
Yeah.
It's doable, let's do it.
All right, so yeah, to generalize, this does not only apply to records. This applies to your type declarations, and it also applies to patterns inside of your actual functions.
Okay.
So you could apply it at the case level as well.
Which is a lot more convenient than trying to thread your seeks around.
Oh yes, yeah, I think it desugars to a seek kind of thing.
Yeah.
Right, typed holes and partial type signatures. So it's a more interactive programming experience with Haskell. Roughly the idea is with typed holes as of 7.8, in a function's definition you can insert your underscore and you get an informative type error. It tells you everything in the lexical scope, what their types are, and what kind of type was expected in that hole. Kind of a taste of what some theorem provers give you, like Idris and Agda. Partial type signatures in 7.10, in a type signature you can insert an underscore to get a warning and the type it infers, and it automatically inserts that type and tries to do the thing with the program. So that lets you kind of fill in things if you're not sure what a type's supposed to be somewhere.
But it is only a warning if it can infer a type.
Mm-hmm.
Okay, yeah.
So these are extensions still though, so it's like if there's a reason they didn't want to just turn them on by default, they would have
Yeah.
Yep.
So how,
done something wrong.
Typed holes itself is automatically turned on in 7.8.
Okay, that's what I'm getting at too. But partial touch signatures is not turned on automatically.
Mm-hmm.
Okay.
I think they're still trying. My best guess would be that it may possibly not work very well with GADTs. In some cases, I think some of those extensions don't have a principal type. So you might, type inference isn't going to help you.
Well, there may not be an answer in this room, but I'm curious. From a specification perspective, are extensions considered stable? Like, as in, like, you know, at what point are they not going to change their behavior, right? Because there's sometimes with some language ecosystems, extensions are kind of like future development, you know, as a way for researchers to play around with an idea while it's
If
stabilizing.
they're not part of the report, there's absolutely no guarantees. However, given how little the report changed, that should give you an idea of how conservative the development culture is there.
Oh, definitely. Well, I'm just saying that, let's say, for instance, there's an interaction with some extension. It seems to me like rather than change the extension midstream while people are using it in their code, they'd be more likely to come up with another extension, or I don't know.
I can tell you a story on that because I did some research on dangerous extension patterns in 2012.
Okay.
The mixture of generalized new type deriving with GADTs and I think type families
Yeah.
allowed you to define an unsafe coerce.
Okay.
Yeah.
Yeah.
This was a bug though. This was a bug though. This
Yeah.
wasn't intentional.
Well, okay.
Yeah.
And
Interesting.
they dispatched a special forces team to go pull the bug down.
They really did.
Yeah, SEAL Team 6 was banging down the door. Well, they don't want people to construct, like, you know, they don't want unsafe courses without you actually using unsafe course. Because the reason in that matters is because of safe Haskell and everything. Like, if you declare a module safe, you can't use unsafe stuff like unsafe course, right? But if you can construct an unsafe course and then declare it safe Haskell, then you defeated the purpose.
No longer sound.
This is interesting because to use an experimental feature that might be changing midstream, it almost sounds as though you need to use like a compile and branch of GHC because by the time the
I think
extension.
they're pretty good
Well,
about
let me
talking about
toss you an
which
anecdote.
extensions are experimental in nature. I mean, like,
Yeah, but people use
But I
it.
can give you an example of something breaking. Generally speaking, when they let things break, it's always a compile time error. Like, it's the only time they're going to allow things to break. GHC 781, 782, I don't know if 783 and 784 fix this, but I know 1 and 2 hadn't. I had to package to compile for 7.8. 7.8 had been out for months, and they never bothered to fix it. You couldn't compile the community resource for packages on the current version of compiler. And the reason is there's a bunch of type classes for mutable and generic vector operations. And the reason for this is that people have a habit of new typing the underlying vector types a lot. So you wanted derivation for it that worked.
Yeah.
That derivation broke.
Uh-huh.
And nobody wanted to write the vector instances because they're kind of nar-nar. So I went through and implemented them by hand. And it was so ugly that Carter Skonewald is trying to get me to include what I did in the book so that people know how to do it. And I'm like, Carter, nobody cares.
I'm with you.
I think your co-author's going to veto that.
Yeah.
So blame it on me. You can tell Carter I said so.
Okay,
This
I'll
is
blame
a
it on
good
you.
discussion because I mean, an alternative would be that you run an extension under like a told like experimental like label or something like you know, like it's prefixed with like exp or something like so you're like really clear like this thing could break and then you roll it in after it's been like you know blessed or
Well, they do
something.
deprecate things, but like an example that is rank 2 types, that's deprecated in favor of rank n types. The reason they made the distinction is that you can infer a principal type, which you mentioned a moment ago, for rank 2 types. You cannot do that for rank n types. That's why we have this distinction between Hinman-Milner and System F. Hinman-Milner's taking power out of the type system, namely actually precisely the feature that rank n types represent, so we can infer things. You can't do type inference on System F or System F omega. Like, that's not a thing.
They're deprecating rank 2 types.
You can still construct a rank 2 type in rank n
Oh no,
types.
I'm with you, but they're deprecating the
Yeah,
extension that
you get a
only allows
warning.
you to have rank
You get a
2 but not rank
deprecation.
3.
You get a deprecation warning if you use the rank 2 types extension.
Interesting.
But you still get inference if it's a rank 2
Yeah,
type.
actually that's kind of interesting
why?
because
Why
Rank-
are they,
Because
why is
rank
I don't know.
Okay.
Yeah.
There was a harvest. They needed blood. I don't know. Something had to die. I honestly don't know.
All in the name of refactoring and dryness.
Well, I actually liked the ring 2 types extension because it expresses intent.
Yeah,
I want my code to stay
yeah,
inferable,
yeah.
but I needed a little bit more
Yeah.
polymorphism
Yeah.
here.
That's
But
exactly what.
apparently, nobody cares.
There you go.
Well, there must have been a reason. I can't.
You can just email the mailing list. Just email the mailing list and ask them.
It's on video.
Yes, it is. Brilliant. Anyway, so yeah, here's what it looks like. We have a mock-up of an id function that takes an a, and here's a type hole. And with no additional information, it'll give you this.
Give
So-
you what?
Like,
All that
Found.
printout.
Yeah.
This is a very long way
The
of
whole
saying
thing.
hello.
yeah, this is a this is a whole
It's trying to
compiler.
give you information to help you fill in that blank.
Yeah.
Right? So you know that the hole has to have type T1.
Yep.
And what is it saying? It's okay. Hold on. It's,
A has a
What you
T.
got, and it's telling you, it's giving you some ideas for what you might plug in, which is actually kind of cool. You can either give it a value A. It's like it's like you're missing something, right? Let me tell you what you can put in there. You can put in A, which is ostensibly a good answer. You can put in ID prime, and you're like, I wonder what that'll do.
well, it's not making suggestions. It's giving you bindings that are in scope.
It would
Yeah, I
make
know,
more
I know,
okay,
I know.
yeah.
It's like telling you what things that fit, right?
Well, we don't have a
So-
lot of type information here. That's really the problem. Like, it makes a lot more sense when you're in the thick of a
Yeah.
function that has more type classes or
What's
constant
interesting
types.
is that
It would have been nice if you told me about these when I was writing Towers of Hanoi.
These are wonderful with the NICTA Haskell course. Like, really starts showing how valuable that is.
Oh yeah.
Well, you know what's
Yeah.
kind of interesting is that Stephen Campbell at Compose was doing a little natural transformation kind of, actually the source code is online, I can point somebody to that. But there came a point to where he kind of had these easy solutions, I'll say easy. And I'm like, oh, and as part of the reason they were easy is that in the comments he was like, hey, look, you can use these functions that I've imported for you. And I'm like, oh, they just plug right in. Like it's almost like cheating, right? And you're like, and then he says, I said, yeah, well, that's good, because I don't know these libraries well enough to know what the names are for these things that help solve these problems. He's like, yeah, actually, you could derive them by just using type holes. Like the implication being that most of them have a single implementation, that are singly inhabited, which is really cool. I mean, it's really cool. Just like it's almost dangerous, right? The idea that you're just re-deriving these things that exist in standard libraries just because type holes let you.
Mm-hmm.
I mean, I don't know.
Parametricity is intense.
I'm
That's
impressed.
what using Ogda will do. Like, in Ogda, if there's one inhabitant, like, it'll set up goals and the holes and stuff, and then it just it just applies the induction principle and starts filling everything in.
I think I need to experience this a little bit more. Like, I want to.
Well, if you imagine there being 2 inhabitants for a
Oh, no,
function.
I'm saying like in my real work. I'm not saying like I can imagine it. I just want to do it. I think it'll be fun.
he must have a real use case that pops up where
Yeah.
single inhabitant, and he's like, I found it.
Well, it
Yeah,
only
yeah.
stops filling the code if it doesn't know like where to go in a branch. So if there's 2 different inhabitants and you know which one you're thinking of, you just give it just enough information, and then it just fills in the rest.
I'm excited.
I think another thing that's interesting about this is you have to know how to read it a little bit, because if you just naively look at this, it's like, oh, I need something of type T1. Well, A is of type T. Oh, I'm bummed. Like, there's no, right?
Yeah.
It almost looks like you have to apply ID prime to A.
Yeah.
And like, because recursion is one possible, like non-termination is one
Yes.
possible answer, right? So you have to know that T could also be T1.
Define your own divergent fixed point.
Yeah.
And also, it's like a mix between advanced and beginner, right? I mean, a rigid type. You now have to know what a floppy type is.
I do bring up the definition of rigid later in this presentation because it is used a lot
Sure.
in the manual. Floppy types.
I like that.
All right. Okay, so here's the other side of it. This one you do have to include the language extension. It uses almost the same like error kind of style. Here's your stuff in scope, figure it out. We expected id prime to be t to t. Yep.
Cool.
And it knows they're the same type this time because you returned A back. Before it didn't know because it didn't have the information.
Yeah, I was nicer to it on the second round. All right, kind of a cute one. You can derive functor, foldable, and traversable, so you don't have to go ahead and implement those.
I want to say this is the one I really love. This is the one I think is kind of
Near magical. I've been meaning to look up exactly what the algorithm is for how they derive, like, what is the instance of
That's
they
actually
derive.
something I've wanted to write like a tutorial on, which it'll
Uh-huh.
probably just end up going into a book. But teaching people how to write like a generic algorithm for writing like catamorphisms for arbitrary data types is actually a really good way to really hammer in how those things work.
Now I'm really curious because I haven't used this. I'm just really glad that it exists. And I'm sure the algorithm's like slightly finicky or something, right? But if you have two type parameters, it won't do it. Is it because it doesn't want to disambiguate, or how does that work?
Probably
Or does it write
picks
both
the-
instances?
Probably do. No,
Well,
probably
the
does it over
type,
the last one.
it's
right?
not like Scala. Your type parameters are ordered.
Two type parameters order.
Yeah,
so
they aren't in Scala, but they are in Haskell.
Okay.
The
So-
type constructors are curried like functions
Right.
are curried.
So it's just going to apply up to the last argument.
I mean, that's how I imagine.
Yeah.
So like either is a monad, but like on the last one, right? Like by default, like that's
Oh,
the
okay.
easy case.
You can find out in
because
2
it's the
seconds by
last-
typing the definition of either and then turning it on.
No,
and
no,
seeing
I
it.
understand what you guys are saying, and I apologize for
Yeah,
asking.
it's-
for
No.
asking Scala
But-
way
but
too
I think it's
questions
actually
about
important.
Haskell.
But I think it's important to realize that that's only possible because the type parameters are ordered.
I completely agree.
Yeah.
I completely agree.
Without that, it wouldn't know like which one you mean.
Or would pick some convention. And, I don't know.
That's the same as just saying like the convention is that they're ordered,
Sure.
right? Because I mean, yeah, I don't know. I don't know what else you would do. I'm not imaginative.
I want to point out derived functor specifically because that one comes up a lot in the context of defining your own free monads.
Mm-hmm.
This lets you skip the boring part.
Well, you can skip the coordinate thingy. Yeah, right, sure.
Well, no, derived functor is different from what you get out of the free functor.
Oh, okay.
Mhm.
Yeah,
fair
those are two different things.
That's,
Yeah.
That's exactly right, but I think that people try to get the free functor to like reduce boilerplate. It's another boilerplate mechanism.
Yeah, but different semantics.
The different
Mhm.
semantics, I'll agree
Yeah.
with you, but anyway, we can talk about this later.
Yeah. I think I get what you mean.
Okay, so there's a few others that allow for derivations, derive generic and derive typable. Those are a bit more nuanced, so I don't mention those here.
You're not actually allowed to instance typable anymore anyway.
Yep.
You have to derive
Yeah.
it, so you can't do evil things.
That's that whole unsafe coerce thing. That was one of the ways to do it.
Yeah.
Overloaded strings and lists. So this allows for string literals to take on other types other than a string, a list of char. And there's a generalization that allows you to treat list literals as something that's not list of A. It's basically just you have a class is string of A, you implement from string for that type, and for example, byte string is just pack. And for the sake of is list, you specify type item A, a from list, and a to list. And for example, for a set data type, it would just be the items themselves in a set of A are A's. From list is set.fromList, and to list is set.toList. So then you can have list literals that are actually sets depending on your context in the program.
That's fun.
Yeah, it makes for pretty list intersection and things like that, set intersections and whatnot.
Type item equal A?
Yeah,
Yeah.
it's like a type function.
Mm-hmm.
Can you
It's-
go back, you went over the overload
Sure.
thing really fast, and I think I missed the slide.
Oh, sure, yeah.
This one's pretty useful for writing, web services, network services, things like that, because you're not really going to use strings much in that
What's the
context.
other one that's just string, the string literals that lets you use a string literal for, what's the name of that extension?
Overloaded strings.
Oh, that's this one?
Yeah.
Yeah.
Okay.
You have to make your thing an instance of the string.
Oh.
Yeah, that's the type class that makes it work.
Okay,
So if
gotcha.
you have your own type.
But
Yeah.
those
make it an
types,
instance of
those
the string.
types have to
Yeah,
already
So if
implement
you,
that instance.
so
Okay,
for
gotcha.
example, if you have a string literal and then you do like +1,
Yeah.
it's going to say that there's like no num given an is string A. because now it's polymorphic
the new
instead.
thing-
Yeah, that's
I think
fun
the new
one.
thing
String
for me,
type. But then you can actually instance, if you want to turn Haskell and PHP, you can instance
Yeah.
num for one of the types that implemented is string, and then we'll pick the one that it can find a num instance for among the string implement. You can make your Haskell really confusing if you want to.
Is everyone
And this
familiar?
is driven by whichever instance is in scope.
Well, okay, so there's no instance scopes.
Yep.
Instances are completely universal. They're canonical.
Is there
This is driven by inference, and okay, so if you pass a value that's a string value like that to a function that expects a text, it's going to just go ahead and unify that information and say, you have an isString A value here. I don't know what type it is yet, but wait, you pass it to a function expecting text. Well, I can just go ahead and unify the information. Now I know it's just text, and it's going to dispatch that instance and convert it.
Yeah, I think I just didn't know these type classes were backing all that. I just saw it.
Yeah,
Yeah.
it was the simplest way to make it work. They weren't going to like make it like some kind of ridiculous.
Is everyone
fiat or
familiar with
something.
overloaded literals in Haskell and how that works?
I didn't look in that one.
I've never looked at it either.
Wait, what?
Overloaded literals.
No, just in the general concept of. I'm just talking about like.
Oh.
I'm not talking about like a crazy.
No,
extension.
actually,
I'm just talking about like numeric literals and strings. Like they actually get desugared to like string literals get desugared or not desugared to from string of that string. So it's like writing. It's inserting that function called for you. So when you have a type that has this instance, like that's like the right thing happens.
Yeah.
It's almost. I mean, is it fair to call it kind of like?
So when you write like 1 plus 2, it's actually doing from integer 1 plus from integer 2. And so that's how like 1 plus 2 can, like that whole expression is overloaded now.
Yeah.
Is it fair to like regard it as like this managed type coercion? I guess.
So what?
Like is it fair to regard it as like managed type coercion?
Coercion.
It's unification.
Yeah.
Yeah.
It's more like a handiness saying that like it's handy to overload literals, so we're going to implicitly like add this function that wraps all literals, right? So
Yeah.
that like the overloading can't happen, right?
The literals are fully polymorphic until you give them a context. That's how that ends up working.
Yes.
Because the moment that you
That's what I was asking about the import. If I import neither byte string nor text, then my string literals are just good old.
No.
List
They'll,
of
Yeah,
care.
they'll
because
stay
like,
polymorphic.
if you have that,
But the only thing it can bind to is list of care.
It
That doesn't
depends
matter.
on what's around that
It doesn't.
expression, right?
It doesn't. It
So
doesn't.
if you end
matter.
up later using that string literal with something else that expects like a honest to goodness string, then yes, it'll end up inferring.
Yeah, but no, I think we should make this point real quick. It doesn't matter if the only instance in scope is list of care. It's not going to just pick it just because it's the only instance in
fair
scope,
enough.
because that would
Yeah,
change
yeah.
the semantics.
Yeah,
If you try to use an isString A value and it doesn't have any way to unify that with a specific instance, I just got done writing about this in the book. You'll have an ambiguous type and it'll complain loudly unless there's a default specified. And for this particular type class, it's probably going to make a liar out of me and have a default for string. Where if you have an ambiguous type, it'll pick the default, and that may very well be string. But as a general principle, unless somebody's defined the default, it needs something to unify with. Otherwise, it just doesn't know.
I think this one doesn't have a default.
That would be very good if
yeah,
it didn't.
I
because
remember-
That's really not.
I remember this because I wrote a parser for internet messages. I think it was like RFC 2823 or some junk like that.
What?
Yeah, and
Yeah.
so emails.
Oh.
Yeah, the email protocol format, and I did one in text and I did one with byte string. I did it with overloading strings and then without, and then it definitely told me, hey, look, you're doing things here that don't make sense.
Yeah, that's why I wouldn't want defaulting, because that just seems like it would get messy. way too quickly.
So
That's
if you
not
don't
a good
use this
idea.
extension, a literal is a string, and
Mhm.
that's it.
Yep,
And
that's
if
it.
you do use this extension, then you should make sure that
And you are going to be using this extension.
Yeah, no, I got it.
I don't know. I don't know why it's not just in the language.
Sure, just make sure that it's unambiguous.
Yeah.
Not true inference.
This is why I use classy prelude.
There are examples where the thing that he was talking about happened, where all of a sudden something that wasn't ambiguous now is slightly ambiguous, and you got to like add some annotations to help it out. I think that's why they just had rolled it out like.
Yeah, that's basically it. They're really like persnickety about breaking old code, even if nobody's using it.
Yes, right. Alright, cool.
All right, so let's try to go into some of the deeper things. We've already had some pretty rich discussions on the simpler things, so this will be fun. GADTs, existentials, GNDs, empty data declarations, and scoped type variables.
I don't know, bike shed principle could apply. People have less to say.
Yeah, I know.
Oh yeah, there is that.
Breeze through these.
Yeah, it's like, oh, it's syntactic. We could have an opinion on this.
Yay. Alright, so GADTs are a combination of a new syntax and a new semantics for modeling data types. The key idea, according to the user guide, I took these words out of it exactly, are that pattern matching causes refinement. That means you know a little bit more information about your type when you start pattern matching. So I'm just going to walk through an example. In practice, this whole GADT thing means that each branch in your polymorphic sum type can carry some information about what should be there, and GATs let us model this. So the example given in the user guide is a language with polymorphic terms that can be literals that take an int and return a term of int. The suck, the is zero, if, and pair, and notice that all the return types on the right-hand side, the final thing that's constructed, is not necessarily a term of A. It's actually a term with some additional information about what's being constructed. That's really powerful. Without GADTs, it would look like this. Term A is lit taking an int, suck with a term, is zero with the term, if term, and pair term.
You probably wouldn't even have a type variable in this case, right?
Yeah, you could actually combine things here in an awkward way that you end up in your evaluation when you're actually evaluating it, that you try to run, let's say, is zero on an if term. And then you're like, what do? You're stuck. So you could have some soundness difficulties in your evaluator. So eval with the GADTs looks just like this. Really straightforward stuff. For each branch, lit I, we know it's an integer, just return it. Suck I, we just 1 plus eval I. Is zero, we eval the t, and then we compare it to zero, and so on and so forth. It's pretty straightforward stuff, thanks to the GADTs.
Go back.
Sure.
Sorry.
You know, one thing about this that I still haven't fully wrapped my head around.
Could you make...
This
Sorry.
is the.
Does everyone appreciate like the magic of stuff happening here?
This is kind of like simply typed lambda calculus. Well, like less than that. It's a simpler language than even that.
Right, so basically it declared the type signature of the constructors, but didn't give you an implementation.
No, they're still constructors.
Yeah.
They're still constructors. You're just allowed to say more about what's
Can
going
you
on.
go back to the previous slide?
Yeah.
Well, how is it allowed to produce
No,
a
go back to the previous slide before that.
pair?
Here, because this is really this. In order to appreciate how that other slide works,
Yeah.
it's important to stare at this slide and see what this slide is doing. I think.
Yep.
Different from the next slide. I'm sorry, it's not. Like I saw the usage, and I was like, wait a second, I need to see this slide.
Yeah.
This is where the magic is at.
So
Yeah.
you have function syntax instead of the normal data constructor syntax, but it still does create just like constructors. They're still just data constructors, but now they're
How would you trust it to pick the right thing for the return value, if it's actually instantiating the constructor?
Well, I mean, when you say pick, when you look on the rightmost part, like Ali mentioned, you can see like term int, term bool, term int.
You're still constructing
I'm gonna
terms.
stick with pair. That's,
Okay.
well,
so you're
actually,
telling it the return type, right? That's what all the right hand
yeah, but
side.
he's claiming in fact I'm actually getting a default constructor out of this.
Yeah,
Oh,
because you pass
yeah,
in
this is
two arguments and you get
This
a
is a
term
funny
of
way
A.
of writing it. So, are you familiar with the idea that constructors are kind of like functions? So, have you ever looked at like the type signature for like left? Like left is like one of the constructors for either, right?
I always just assumed type constructors were functions.
Yeah, no, that's right. That's
Yeah,
right.
yeah, that's exactly
so
it.
Now we're using
Wait, you
functions.
said type constructors. You might have meant data constructors.
Sorry,
Yeah.
data constructors.
Yeah.
Sorry, data constructors.
Yeah.
That's what I meant. Yeah. So we're just using like normally function signatures you write with this arrow business, right? And so we're just using that again for constructors now. Whereas normally constructors in Haskell you don't use like the function signature.
Well, okay, I'll stick with the if line. So
Okay.
if it's going to return a term A out of 3 arguments,
Yes, that's right.
why should I trust it to do anything useful?
Because it's
just
saying
data.
that, like,
It's right.
it's saying that the type of the if that's the if is a thing that contains a term bool, a term A, and a term A.
Uh-huh.
And the type of the if Like the type that you of this of the
Do you have
of
code
one
for
of the
this?
things is a term.
I don't.
And it's
Beyond
just
what's in
different
this
types
line.
involved, right?
Really
Because it's
quickly.
essentially a tuple of three
And
things,
we
right?
can put together
Like
like,
there's
a
no
malformed
like whereas
expression.
okay, I did make this analogy
without
with
the GDT
constructions
and then
functions,
add
but
with, and
constructors
then
are like the simplest
think
kind of
maybe
function
you
because
just
all they do
saw
is like package things up and
the
then
type
hand
checker
back
can
the thing and
plane.
say,
That would be
oh,
good.
this is a
Across.
term A.
You want me to do that real quick?
Yeah,
Right,
go
so
for
there's
it.
nothing to trust.
Okay.
You give three arguments. It's like okay, here's your
I think we have a
three arguments.
simpler way to explain this, and that is just write code that is broken but type checks,
Sure.
and then make it not type check.
Yeah, go for it.
So-
That's the only other thing I was gonna do on this page, is point out where the refinement was happening. It's happening, I'm
Whoops.
sorry.
What in the?
Okay, go ahead.
Oh, I can't. All right, it's not gonna. All right.
Windows key.
All right. So I'm gonna bring up my Emacs here.
Go Emacs.
Now
Okay.
Curtis is engaged.
And source GHS. Okay, so I want. What do I want here?
So we want the term language.
GADT. Yeah, we want our
Good.
term.
GADT.
It's the Australian spelling.
Which is all that matters in that.
That's one of those things, isn't it?
Okay, so importantly, we're allowed to say that these constructors contain values of type term, but we're not allowed to assert what type its argument is. We're only allowed to say it's a term. We're not allowed to say term of what.
Okay.
So that's an important difference here.
You'll
So
have to kill the type variable on the data line.
kill what? Yeah. All right.
No,
So
but that's actually really interesting because on every one of these terms,
could be anything.
Yeah.
So with that in mind, just
Wait, did that actually compile?
well, I mean,
Oh.
I'm not compiling
Oh,
anything,
sorry.
but I can do like that.
Yeah, that's
Okay.
what I'm saying.
That
You'll-
should
you
probab-
kill the type variable on term A,
Yeah.
Yeah.
or do that.
or do that, yeah, exactly, right.
Oh, you mean just kill it? Yeah. Okay.
Because we're not
Yeah.
using it right now.
Yeah. Okay. So there we go. All right. So we can construct terms. Oh. Well.
Yeah. We needed.
All right. See, these are the practicalities we need to care about. Driving show.
Hooray.
It's fine by me. Okay. So what's something that doesn't make sense? Well, okay. If can we if on
Little one.
term true?
Okay, sure.
That makes sense. But does this? Not really. But the thing is that it's gonna.
Lit term is not a data.
Oh right.
Yeah, you'd
duh.
have to be all like lit.
Yeah, it's just. Yeah, it's all lit. I don't care. I just need something that breaks. Okay, so here's the problem. It's gonna actually let us like pass this to an evaluator. Now the problem is that now our evaluator becomes a partial function that can fail. Well, that sucks. What if we just didn't allow people to construct invalid data? With that mindset, what we can do is get rid of that and go back here, data term A, where lit. Okay, so now we're going from int to term, int.
I'm gonna propose something that involves a lot of typing, maybe. Is it instructive to write our first version of the data type in just GADT syntax? Do people care about that, or?
You know, I'm actually following it me personally, but I'm not open to the ideas. I would ask the question if anyone in the room needs a little bit more help. 'Cause, you know, I don't wanna do something for the sake of doing it.
Sure.
I don't use GDT syntax by default because among
I'm with
other
you.
things, derivation breaks, inference breaks, and pattern exhaustiveness.
Oh yeah,
breaks.
I'm not talking as a practical matter.
By default.
Yeah.
I was saying
Yeah.
just to, I don't know.
Oh, there's
So-
kind of a cool thing. They have a separate extension called GADT syntax, which doesn't bring in the GADT semantics, but lets you use most of the syntax.
Okay.
And in that case, you can keep the deriving stuff.
That's interesting, I didn't know that. But man, there's so many exceptions.
Yeah, it's 170 pages of like extension literature. I did a lot of reading over the past 2 weeks.
Okay, so I'm gonna load this. Oh look. Oh, we need a pragma. Oh my dear. What are we gonna do? If only we had learned about these things. Okay. What? What?
Pretty much.
Oh, you have a thing there that needs to be const.
Show needs to take an argument.
Right. There we go. Alright, so that example, yeah, that doesn't type check now. So now you just can't construct bad data.
And so when you were back for the native one, you had started with doing parenthesized term A's, B's. Could you put a term bool in the old style?
Let's try that.
Chunky commented out.
Yes. Alright, so what does this gotta look like? We've got lit, int, yeah, that's fine. Alright, so we're gonna say
Simply int.
term.
Yeah.
This is kind of
That's
That's
a
int.
bool, right?
well,
Oh,
no,
yeah,
but
yeah.
that's the problem is
Yeah.
it's going from int to bool.
Yeah, we can't specify the return type.
Yeah.
Okay, so that's the remaining weakness is you can't control the return type.
Yeah.
Yeah. So that's where phantom types isn't enough, which is roughly what we're doing here.
Yeah. Because like
That basically answers the difference between the two.
yeah. So that's the thing is that like these things seem really hard initially when they're just like dropped in your lap and you don't have any context for it. But if you sit there and you're trying to like get something done and make something type safe and you can't because you don't have like the language for it, then you develop an empathy for like, oh yeah, I needed this.
Okay, so how many, does anyone here not understand GADTs? Like, or like, you seem like you reached some epiphanies or like conclusions.
I'm good enough for now.
Okay, yeah.
It looks like I'm kind of getting the gist of it.
Okay.
So, like basically, it's like you have like a function style declaration for the data type constructor.
And also it allows refinement. It allows you to be very particular on the kind of you know, like you don't have to just get an A out at the end. You can get like a specialized version, or you can say only a specialized version is used for the data construction. So you can, you know, and you can maintain polymorphism where you want it, and then you can refine, you know, where you need to. So I didn't want to shortcut anyone who was still figuring out, because the next question is.
No, I understand. I now understand GADTs much better than I did 10 minutes ago. So.
Oh, awesome.
Nice.
The next question I have is whether people have heard of reasons to avoid GADTs, or because like this is getting to like, you know, conversations you and I.
Well, I rattled off 3 of them.
Oh yeah.
Inference, derivation, pattern matching is awesome. That's the latter of which they're working on.
The follow-up question is whether anyone has heard of alternative methodologies that obtain the same kind of benefits as GADTs, but are more powerful, or, you know, like.
No, there's singletons, but that's going further in a different direction.
And especially when you get to this very, very particular example, which is often the example used for GADTs.
It is.
It's like, like the expression language that needs some refinement.
Yeah, I can't think of a.
I think it was on the FP Complete blog. This is one I was just trying to plow through, where he basically just did everything you can do with GADTs, but with straight functions, including reading from an IO stream. Now that got ugly.
Yeah.
You know, it was all done with types.
So if we ever have a little grammar, much like this little grammar here, or this AST, if we run into this problem, is GADTs like the tool you lean towards, or is there?
No.
Okay, so what is
You
the?
just wait until you need the ability to talk about your type parameters.
No. My
That's
point
what
is
he's
that's
saying.
right there. It's right there in this example. So it's very possible somebody wants to make a little mini language. That mini language has.
Well, the thing is like you only need the ability to do this if you need like an open world polymorphic type variable in there. If you can enumerate every inhabitant you expect to be contained therein, you can just make it one big sum type, and then it's as type safe as you want. The problem is when you want to start doing arbitrary subsetting and stuff, that's what GHDs makes convenient.
Right.
Because if you need to do arbitrary subsetting, then you have to create different, this is why I mentioned singletons. Singletons makes that subsetting and type constructor proxying of individual inhabitants a lot easier. But I've done it manually, and you can do all that without GHDs. It's just like for example, if you have like a sum type enumerating some particular set of inhabitants, and then you're like, well, I want members 1, 2, and 3 out of these. What you're going to be doing is creating a subtype, but just an independent type for every single inhabitant, and then your sums are just going to pull in those independent singleton types. But doing it manually is annoying.
Yeah, and the alternative I was reading about was the only reason I could see you want to go to that trouble is you want the Haskell compiler to compile your DSL type safety without any intermediate AST.
Okay. Oh, interesting. Okay.
Yep.
Okay.
But if you're but like that's literally if you wanted to compile and run the DSL. If you're just reading something in and you're going to interpret it, I didn't see anything in there that motivated me to not just go with standard compiler technology.
Okay. Interesting.
Wait, so would they ever like add this to the next like version of GHC, the GHDs?
There's no next version of GHDs. There's
I mean like GHC, next version of
So this is in
What?
GHC. It's just you have
This-
to enable it.
Yeah.
it's there.
Language.
Okay.
Yeah.
It's been there for a while now.
What's that?
Well, it started with phantom types and then it became GHDs, right?
Yeah. That was like 2009 maybe, wasn't it?
That's not
Yeah,
really been
yeah. It was a while
quite
back.
so
It was a while back.
active since like this
Like
Haskell
phantom types
2010.
isn't even.
So, and
It's just
still
there now.
what you're saying, like from Compose. So, there's a little bit of like social issues that are involved with respect to this stuff.
Yeah.
So I think that because of the social elements, there's kind of just been a trajectory of layering on the extensions,
Yeah.
as explicitly. So I kind of like it because there's so many extensions that it's kind of like nice to default to. You're like, oh my god, what is this weird one? You're like, you go. First thing you might want to do is go to the top of the file. To me, I think it's.
When I'm writing applications that aren't intended for public consumption, I put my pragmas in Cabal and I turn on Classic Prelude and I basically just get my nice big more magic switch and then I don't have to give a fuck what anybody else thinks. It's really nice.
Okay, interesting.
Yeah, and then I don't have to enumerate them all at the top of every file because it's like, a library, yeah, somebody's going to read that.
What does Classic Prelude have to do with this exactly?
It's
just-
just
talking
part of
about
the more
magic.
magic switch.
Oh, okay. Okay.
I'm just a really
He wants a
huge-
richer default Haskell experience.
Okay.
Is there a
Oh, so what
literal
you basically
thing
the basic
for
thing
more
that
magic
you're saying that
switch?
you can enable these
Yeah.
in small files.
I could make
and then
I
not
could
have to have them
hack in a
file
pragma
itself.
in the GHC and use my own version of GHC with a more magic prelude.
I want
Or-
you to
or
do
Well,
pragma.
let me ask you this, Alex. So
Alright.
you're now doing Haskell professionally.
Yeah.
Congrats.
Do you
Thanks.
Yep, congrats.
So there's no right or wrong here, but socially, do you feel as though in a team, do you want to keep the pragmas in the top of the file, or do you feel like you might want to take common ones and kind of stuff them into a Cabal file so you don't have to do it again?
The only common one that we've stuffed into a Cabal file is no implicit prelude. I've seen.
That's a good one. I
Yeah.
like that one right off the bat. I thought you were going to say overloaded strings.
When working with Curtis, overloaded strings, we definitely had that one.
Okay.
I could see overloaded strings in a web app thing. Where
Yeah.
like everyone's just gonna assume that
It's
every
just a
string is
given.
overloaded anyways.
Yep.
Yeah.
So why not just stick it there and not have to have an extra line?
I'm sorry, I was just beaming off the idea that no implicit prelude. Like, I'm sorry, that was like I actually ignored everything else.
Nothing else is important.
No, I just thought it was like there's.
Well, that's a given if I'm using classic prelude, right?
Oh, that's true. No, that's true too.
But the reason I use classic prelude specifically is because the mono traversable classes unify text and byte string with everybody else.
Wait, what's this?
Mono traversable is nice.
Mono-traversable. The difference between classic prelude and the other fancy, really honestly, I don't think there actually is anything remotely like classic prelude in fanciness, but it's so you have like functor, foldable, traversable. Well, mono traversable gives you mono functor, mono foldable, mono traversable, and they're actually more general than the polymorphic ones. So monomorphic comes with kind of scare quotes because it's using a type family to dispatch at the type level an element type. So you can still use it for like list, right? Like there's a mono functor for list, but it lets you handle things like text and byte string, which don't have a type parameter because their element type is fixed. So you just add like the the element type of byte string is car8 or whatever it is.
Why
And you just huh?
Or what benefit do you get out of it?
It means I can use the same folding and traversing and all that functions with text and byte string that I use with everything else. I don't have to call out their
Beat out folder.
Do it for something that has a type parameter.
So like my plus
With
plus,
byte string, where's the
my-
type parameter? No type
my
parameter.
plus plus,
I'm absorbing.
my
Go ahead.
plus plus,
Yeah.
my concatenation operator.
Yeah.
If I'm using classic period, I can use that equally with lists, sets, vectors, text, byte string. Everything just works. My plus plus now acts like the plus plus in like ridiculously dynamic language or something, except it still types it.
It,
Why not use the monoid?
Yeah.
You can. I'm okay. So I used a bad example.
Because that's what I was doing.
But-
that for it specifically for overloaded strings.
Yeah.
Everywhere
Well,
I speak I just use.
that's
the monoid.
actually if you look at classic prelude, that's actually what they did. I think plus plus is just plus plus is monoid, and then the less than greater than bracket is semigroup in classic prelude.
Coolio.
Yeah.
Classic
so that's
prelude's
pretty
nifty.
nice. Yeah, it's the only problem with classic prelude is that if you don't like mono-traversable, you have no reason to use it, because it's like half the prelude's now part of that universe. But it's nice.
How do you spell classy?
CLASSY.
Okay.
Yeah, because it's type class heavy.
No, this is
Yep. Yep.
Yeah.
Is it? Oh,
That's the trick to it.
Mm.
it's just what I needed right now.
All right, so we G80Ts and some things to watch for, which Chris enumerated. You can no longer just use deriving on the data construction clause. You can use standalone deriving, or you can manually specify your own instances. It will probably interfere with your type inference.
That's interesting. You can do standalone deriving, but you can't have the deriving clause on the. Okay.
Yeah, standalone deriving has a little bit more specificity available to it. Yeah, it's in the user guide. They actually said like it's a little bit more flexible than the one that comes with data.
You guys run some kind of inside club where you know what standalone deriving is.
Yes, we are.
It means it
Got a
like
secret handshake.
it means strictly that you can just say instead of data color equals blah 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 deriving show,
Yeah.
which normally just comes attached to that.
Yeah.
Imagine it putting deriving on another line entirely, and you specify.
You can even have your data defined at the top, and then a bunch of functions, and at the bottom put like deriving blah.
So you can
for
like
this
group
type.
all your
So if you have
derivations
multiple
together if you
data.
want to.
Like,
Well, you say there's like you say what type. And
oh, okay, okay, gotcha.
Yeah.
Deriving
It's not
from-
it's not like it's not
Okay.
gonna infer what you meant. Like
Well,
Deriving-
it's not apply to all the data in the file or something.
I
Yeah.
don't think so.
No, it's like deriving constraints on this data type, and they use symbols for that, and that's my
Why does it
English
have
version.
More information. I don't understand that.
But also, what is useful about standalone deriving? Like, who cares?
There's some good reasons in the guide. They actually describe like I can't remember the reason.
I've had to use that when I need to like, if I want, I mean, a really
Can you do it
obvious.
in a different file than the type was
With-
defined?
I'm not
Yeah,
sure.
that's what I was going to talk
Or
about.
somebody
The-
else's type? Or
Yeah,
something
that's
like
what I was going to explain. I was
no.
working with
Yeah.
a bot
Yeah.
for Twitter,
that.
and I needed to add typable and some other stuff to the
Oh.
types in the Twitter types library
That's cool.
because I was using acid state, and I'm really fucking lazy, so I wasn't gonna like write those out manually. So what I did is I just used standalone deriving to generate all the type classes.
Does you still get orphans warning?
What?
You still get warnings about orphans?
I don't know.
I would expect it to be.
I don't know. You don't even care.
That really.
That's a fair
I
question.
was deriving typeable.
Yeah.
Clearly, the point at which I care about orphans had passed.
That discussion you just that's funny. That discussion you just said definitely converted it from like a syntactic curiosity to like
I
really.
think there's some other reasons they talk
No,
about. I can't
that's-
remember.
It's,
Like,
yeah,
reason.
but it's one of those things you can just pick up organically. Like it's not like I thought, oh, I need to use standalone deriving. It's I loaded my code and it said, hey, dummy, use standalone deriving. I'm like,
Did it really?
yes, compiler,
Did it
I'll
recommend
do
it?
as you say.
Okay.
And then I did, and then it worked, and
The-
it was good.
It's the Microsoft Clippy of compilers. We can see the influence here.
I just do as I'm told.
Hey, let's get to rigid.
Yeah, rigid's in here. So certain things must be rigid, and what that means is that the compiler knows the type of the term under consideration. That means it's not going to be polymorphic. You've narrowed it down to something very specific, and this might require type annotations, but it might be able to figure it out based on your pattern match refinements. Like when we did the lit I in the little language we defined, we know that I is an integer because our GADT specified that was an integer. So rigidity just means the type is known, it's bound to something.
So here's a question.
Wait, why doesn't it just tell you that?
Why doesn't it just what?
Tell you what the type is.
It can't figure it out.
No, because the
Inference.
thing that's rigid may not be the thing you're trying to solve for.
Oh, and it just knows that it's rigid, not polymorphic.
Yeah.
But that's all it knows.
Yeah, you need it to get to the rigid state.
Interesting.
I noticed another typo. Okay, cool.
I don't see it.
You have 92
Go
slides.
next.
I think you can be
Next,
forgiven a
next.
typo.
When we see it.
Next, existential quantification. Typos don't exist. All right. The key intuition behind this one, and it hit me today when studying it, is you want homogeneous processing of heterogeneous collections. That's kind of one intuition for existential quantifiers. The example given in the guide, not on here anyway, didn't get that far, was literally a Lisp-like type that had two branches. One of them was nil. The other one had a for all a cons a with a function from a to bool. That a can vary. So you can have a list of that contains an integer and the function even attached to it. And then in the next element, it'll be a character with two upper or is uppercase or something. And what you're saying with that data model is for this entire heterogeneous collection, the only thing you care about is that you can convert your types into something that goes to bool.
So the only, or one thing I would suggest when talking about existential quantification is the collections argument that you just said is valid, but it's a little bit more special case than the general idea of existential quantification.
Oh yeah.
And there's another way of explaining it. I don't know that it'll work better for other people or not, but the way I like to think about it is in terms of like modules and packages. So I sometimes I'll say something, I might say it inaccurately, but this is how I think Ben Pierce alludes to it in his book. And
Are you
I
going to say modules or existential types?
Mm-hmm.
essentially, but cut me some slack. I haven't gotten there yet.
That's fine.
So so the idea is that you have a package. The package has this abstract notion of a type, and you have various like things you can do with that type. And so you have things that can create that type, things that can consume that type, but you don't know what that type is. But you know it exists, and you also know that it is exactly one type. It's not like you can do these functions for any type. You can just do these functions for a very specific type. And there's a way of illustrating, like, there's a code sample that illustrates that rather nicely. And what's also nice about that is that it gets you away from worrying about this very specific problem that people normally have, which is like the homogeneous processing of the heterogeneous collections. Like that is definitely a problem. Like, hey, I want to have a list of, I want to process like a list of fruits, but you actually have like apples and bananas and stuff in there, but there's no subtype,
That's
right?
a sum type.
What's that?
That's a sum type.
That, yeah.
I haven't used this for heterogeneous collections. I have used it when I needed to introduce a polymorphic type variable, but I didn't want it to percolate up to the type constructor. So I just did a for all, and I introduced my existentially quantified type variable there, and then it told me, hey, you need to add the, see the pattern here? But yeah, no, I've done this when I had a phantom type variable that I didn't want to percolate up a big hierarchy of types.
Yeah.
Because the problem with phantom types is you have to mention them in everybody that contains them. That's one of the problems with like doing like the tree of hierarchical types. So if you don't want your phantom type to percolate all the way up, you just pick where you want it to stop in the hierarchy, and that's where you existentially quantify that type variable. And then you no longer have to worry about it beyond that point.
Existential phantoms are nice.
But it also means you're not allowed to know or really do anything about that. So you just have to pretend it's not there.
When I looked into this from a packaging perspective, there's a case statement kind of like thing that allows you to get, like, you know how I said like you can think about it as a package and there's a type and you have these things in scope. There's a case statement, like I'm talking off the cuff here. I don't have the code sample in front of me, but it compiled and I was like, oh, that's exactly, it works exactly like I want it to. You can get those, I'm calling them methods. Those
Methods is
functions.
fair.
Well, I don't want to say methods because it's like OOE, but you get those functions in scope within your case.
Mm-hmm.
So it's kind of like, the case ends up unpacking the package.
Yeah.
Right. Okay. Right.
Yeah. It's a kind of, you can do like MLE module kind of things using this, and you can do kind of object-oriented interface designs using something like this.
Yeah, there you go.
Yeah.
Before I ran across this was one of the blog posts where you saw it.
Yep. Yasad uses it.
In the I believe, and I used it for a bit. I worked it out though, which was I had a type class, some sort of 2JSON-y type thing, but it was their type class. Do you know what I'm talking about yet?
Persistent.
No, for ESOD.
Hmm.
They have a typable, or not typable, the thing that sets the media type on the response.
Oh.
And basically, my A had to have an instance of 2JSON. So I wanted to implement an instance of this type class where anything that could be turned into JSON was valid.
Yeah.
There exists an A for which can be converted to JSON.
This is like Lane's thing.
What's that?
This is like Lane's.
It is. We have a code sample in our Haskell stuff that is similar.
Instead of 2JSONs, like in some HTML thing in Blaze. It's 2HTML.
But I'm interested in seeing if we can refactor it.
I think in that case, his use is justified. I mean,
I'll look back at it.
it's reasonable. It's not the. So do you know why? Okay, I don't know. Like some people call this thing an anti-pattern, and I don't know.
Essentially quantified types.
Yeah.
He didn't use
They're
it.
not terribly common.
Sure, and I'm sure there are many cases in which like there are other solutions that don't require like treading in these waters, but I'm not like convinced that universally they're a terrible idea.
Well, part of the reason people object to them is that if you have something that's
is it the hiding of the type that people will
no,
do?
it's like you're doing a final encoding and an initial encoding when really you should just do a final encoding, which is a type class.
Say it again.
You're trying to embed a final encoding into an initial encoding, which is a data type, when really you should just be using a final encoding unless something really weird happened. Like my case where I have a phantom type I'm trying to hide, like I don't want to get rid of my initial encoding, but I had a phantom type and I want the type parameter to go away. That's a relatively specialized narrow case. That's not
The
like the
final
general.
encoding, doesn't that require a commitment to what you're finally doing? You know what I mean?
Not necessarily. Please continue.
Yep.
Oh, yeah,
We'll go
okay,
full
okay,
Oleg on this later.
Okay. Generalized new type deriving. So it mixes the machinery between new type and deriving. So you can derive any type class that the underlying type has instances for, and this just kind of makes it a lot nicer to use your new types. Like you can have a new type age equals age int, which hides the fact that an age is an integer, and you can mix them up together. And then you can just derive num, so you can add ages together if that's something that you want to model, which makes no sense, but sure, if that's what your code base is into.
Generative types, like a term that people use?
Mm-hmm.
That means what exactly?
It means, I saw it in a paper by Stephanie Weyrick, and she was using generative types to refer to new types where you generate a new type, pun on that one, you generate a new thing from something you already have. ML modules with their functor system also are classified as generative types.
Well, I wanted to get at the idea of this, of whether to use generative here is related to that. Does Haskell have anything like this?
Sorry, what?
Like this thing in Haskell?
Yeah. Or
Wait, what?
This isn't
We're
Haskell.
just
Yeah.
You can use this right now.
No, I understand what you're saying. So
This is
no. So we're just talking about generative
this
types
is-
as an example of new type, like new type.
New type is a
I
generative.
understand,
Yeah.
But it could be much more fancier than like new typing.
Yes.
Like that general term. Okay, gotcha. Okay.
Yeah.
But the idea is that like ML modules give you a way to like patch behavior for types. Haskell kind of flips it around. It says you can't change what a type class means for a given type, but you can generate a new type create a new type with new type, and then you can reuse all the existing behaviors you want to leave alone, and then you can instance the behaviors you want to patch.
No, I'm sorry, I just caught off guard.
Yeah, this is just a way to save you having to instance everything.
It's just the generative type, because it alludes to this other facility and this other discussion that's like.
What do you mean, like generative modules? Is that what you're asking?
Yeah.
Yeah, exactly. But like that's not on the table. That's not what we're talking about. We're just talking about new types.
The problem with using the word generative there is that generative, with respect to ML modules, is used to distinguish it from applicative modules.
Yeah.
This is a different sense, I think. I think Weyrich's paper is better way to get that framing.
Well, also that yeah.
Because generative in like ML family culture is different from the generative here, I think.
I think so too.
Yeah.
I think so too.
It's a pretty good 2013 paper. It's recent stuff, and it's a good Google term for looking at kind of the literature around generating new types from existing types.
I would argue you should just read anything Weyrich writes, and anything she writes you can't understand. Find a way, because it's really good.
Yeah, Eisenberg stuff is pretty good too.
Well, yeah, she's his advisor, right?
Yeah, I think so.
Yeah. So yeah, both of them are really good. I mean, Eisenberg's the one we're getting singletons from, so.
Mm-hmm. Yeah, he's also the one that came up with role annotations and roles, I think.
Really?
He's he did the last year's ICFP talk in the Haskell workshop. He's the one who described dependent Haskell and then the role machinery underlying that.
Oh, okay, cool.
All right, back to generalized new type deriving.
Yep. So you can do cool stuff with this.
Yeah, y'all haven't talked about how cool this is yet.
Yeah. Actually, Chris gave some really good examples earlier with the whole hackage thing and how they have their whole vectors thing and they don't want to, you don't want to implement things. So, yeah. This is a nifty thing to use if you're going to be using new type a lot, which is, I think it's generally accepted as a good Haskell code pattern, so you don't have stringly type things everywhere. So
yeah, I mean, I don't really know, this is probably the cleanest way I know to be able to take an existing type and, change the knob on, one behavior and leave the rest of the stuff alone. Because, the way you do that in, Ruby and other languages is you just, open up the class and you're basically mutating things, right? But we don't do that here, right?
We're not savages.
So, this gives you a really nice way. And, I know a lot of people want ML modules, but I actually really like this because one of the nice things about new types is that it's a different name. You can see that it's going to be different. You don't have to worry about okay, is my ML module going to transform it, and then is the same type going to suddenly have different behavior here or there, that kind of thing. You always know because the canonicity holds within a particular type.
Yep.
So big fan.
There goes my empty slides on it. Enjoy the white space.
Oh, that's okay. This particular extension is actually. Oh, have you used it?
No.
Oh, you missed out.
If you start new typing the crap out of your code, you'll start using it.
This is not the craziest one. It's there's all these great type class instances that exist on new types of wrapper, right? You let's say.
Wait, is that you have one function in it or something? You can
No.
words.
It's got one constructor.
I'll restate a little bit of what Chris just said.
Yeah.
But let's say that people are talking about stringly type stuff. You have a string, but one of your string might be first name, and then another string might be last name. Why not have a type that cleanly wraps that string, so you don't have to talk about string and string and string and string? It's at some point, why are you going to type?
If we wanted to give them an example, we could just when Ali's talk is done, just show them Bloodhound.
Yeah, sure.
Oh yeah.
I new typed the ever-loving bejesus out of that. So.
But your underlying type that you're wrapping might have all these really cool properties, like a show instance or a read at time or no effect. I forget what I said read. But some kind of instances, right? So your wrapper clearly has those instances too, because all that has to do is delegate to the thing below it, right?
Well, not clearly. It has a.
Morally.
No, there's an isomorphism. That's why you can get to the instances.
Well,
But that isomorphism only exists because you have this clear.
Clearly.
No, but I respect. Yeah, respect the important part is that for the most part, you want to.
I've run
Yeah,
into
but
Rails
you can't
guys that
assume
think
it
Rails
because
is
you made a
clear, so
screw
I'm a little
as
bit sensitive to words like that.
Fair enough.
Yeah,
Well, the whole-
what we think is clear is.
If I understand it.
Isomorphic
you can
JavaScript.
mess with one of the-
Not necessarily. But here's the thing. This extension is for the ones that you do you want to copy over.
I know.
Yeah.
But it's,
And maybe that gets
But you
to the
can't-
delicacy
you
of
can't
Chris's point.
it can't do it automatically because you might want to mess with them in a way that breaks the
Oh
rest
yeah, that's why.
No,
there's
that's-
no automatic.
Well,
yeah.
no. It's not because of that. It's because what makes this generalized is you're not just deriving the stuff that we have derivation for already. Maybe this point hasn't been made clear yet. This is for even like if I invent a type class, okay, GHC can't derive that in general because it doesn't know what it means, right? But the thing is, because of the relationship between new type and the thing it wraps, that isomorphism, it can do that for any type class in the entire universe. So even if I have like a fairly large set of type classes that my types need to instance, if I use GMD, all that work goes away, and I can have nice, more cleanly typed things, and I can patch behavior, and I can, feel like a nice little Haskell
like
genius.
slightly different things though, but they all relate. They're all true. So that's the good part.
What were you gonna say?
I was going to say, I think the coolest example I saw in my line of work, web development,
I do the same
was
thing.
like Scotty. So let's say you're building up a little web stack, which is going to be some crazy monad transformer stack, whatever, reader T, writer T, state T, whatever, blah blah blah. You don't want that type just going all over your app necessarily. So you can new type it, and then use generalized new type deriving so that your new type is also this monad.
Quick
You
point
can also
about.
use it to pull through like monadic interfaces and stuff on the new types, and that's pretty useful.
Well, the advantage, most people use a type alias for that. The advantage of a new type is that when you get type errors and you use your type alias, you'll get the big ugly thing. But if you use a new type, you don't get the big ugly thing. You just get the new type. So if you want an opaque like wall, that can be better.
You know how much I love those.
Yeah, when I was
I know you're fucking with me. I just don't know why.
Okay, Ollie, how many more extensions do we got?
Empty data decals and scope type variables, and then that's close to the end, yeah.
Okay, cool.
All right.
I don't want to distract from
Let's go ahead and run through the rest of these, and then we'll come back and discuss some more. So empty data decals. The basic idea in this is you can have a data definition that doesn't have a constructor per se. You can say like data void, data sensitive, data information level A. So polymorphic on that, and it's almost entirely used for phantom typing techniques. They serve the purpose of tags, things that you can't construct, but it lets you model things at the type level that should be true. I think
this is a technique where there's like a random type variable that you just set this one of these and then it.
Yeah, it's a way to track like state transitions and stuff.
Another recent use case I saw for it was in, I think it was Don's bot on Twitter. I forget what his site. Yes, there we go. Yeah, he gave a great presentation on like really recent real world Haskell for some of the stuff he does, which is like currency and trade stuff, the financial sector, and there was like phantom types for each of the currency representations, like data GBR, data USA, data Canadian dollar, and it made it so that there was strict transformations between those, so you never mixed them up. But you didn't have them represented as a sum type. It was a little bit more lightweight than that.
Oh, this is cool. I'm sorry. It struck me. I see why it's useful. And I also see why you need it. What would you do without this? Like, if you wanted to use phantom types, what would you do without this? Like, there's not really like a great workaround, right?
You would, it's.
Yeah,
I mean,
yeah.
smart constructor.
You just declare the constructor and never use it.
You have to use a smart constructor kind of approach to make sure that like.
Yeah, well, smart constructors kind of let you do a lot of things that we've been talking about. They're just not. They don't really adhere in the type themselves.
Yeah, right.
They're just like, you have to use this if you want to stay safe.
Yeah.
One use I saw for this technique recently was somebody was writing a non-catenable deck implementation.
Okay.
And they ensured that their code was type safe in Haskell with the use of phantom types. What they did is the implementation was in terms of a stack. And to make certain their stack transformations were safe, they used these phantom types, red, yellow, and green, as basically a coloring algorithm, and then they defined what the valid transformations in terms of color transitions were, so that they could never violate this, like the graph of like state transitions. Code was a little scary, but I was impressed.
Very nice.
Yeah, it was really cool.
Yeah, Phantom types are
Oh,
one
is
of
that the one you sent me that link of?
Yes, it
Oh,
is.
and I looked at it for a while.
What?
Today's a day for sudden epiphany.
Yay. I'm glad that this is bringing that on. Scope type variables. So it allows in type annotations in more places than previously allowed, but it's more than just annotations. They actually represent rigid type variables. I don't get too much into that. The user guide has better definitions, but the specific places you can deal with these are a declaration type signature, expressions can be annotated, patterns, class and instance declarations, and
Is that an example? Okay.
yay, I actually did something.
I wasn't quite getting what's going on.
Okay, so without scope type variables, we're trying to annotate that X over there that should have type A. And the compiler doesn't really understand that because the A is not really in scope. It's just part of the signature. We bring in explicit for all and scope type variables, and then we can explicitly talk about that A as a variable in scope. And now the compiler understands what we're saying there.
Can you go back real quick?
Sure, here.
So,
No, sorry.
For all
There.
not turned
Right
on,
there,
that's
yeah.
also an extension? Like, I thought that's
I-
interesting. I didn't
Well,
know.
yeah, it doesn't do a lot, but yeah. So I want to note on something. Ali described it as a rigid type variable. The reason is that you're not introducing a new polymorphic type. You're binding it to whatever A got bounded in the enclosing type. That's why it's scoped, because you're referring to what already got made rigid by the function type.
Is the explicit for all required here?
Uh, I'm
I
not
think you can add
100%
them in
sure.
wherever you
I
want
mean, the limit of the A scope is G. It's not.
Well, ordinarily the limit is actually the type signature. It doesn't. Type variables don't exist outside of type signatures by
Yeah,
default.
but the for all. Okay, never mind.
Yeah, the for all is just making explicit what's already the case in Haskell, which is
True.
all type variables are univisibly quantified in the leftmost outermost position.
Interesting that they forced, in order to use scope type variables, they forced you to use explicit
Well,
for all.
I don't think we've actually verified that ever.
Okay.
We have not.
Yeah, we.
Yeah, that needs a check.
Okay, no, that's fine. So I'm sort of like thinking about
I don't
it,
think you
like,
do.
Well, what's nice about this example is like it's making a little clear about where A is being bound by having the
Yeah,
All
sure.
right,
you
but
don't-
if
you don't
you
have to
had not
scan the
written
entire
the
line.
type declaration for G, then again it would complain about no A.
Yeah, the A doesn't have an. It's not introduced. That name has not been bound. Okay.
So it's like saying that A is like not a variable, it's like a type variable, the for all, basically? Or
Yeah.
like limits it to that.
Yeah.
It's, okay, so the scope type variable, what it lets you do is, so in the first case, right, so F colon colon blah blah blah, like implicitly there's a, Haskell doesn't force you to write this, but implicitly there's a for all A dot, blah blah blah, right?
Okay.
Okay, so normally that A is introduced at the for all, and it only, its scope is the extent of the type signature. Right.
Yeah.
So then when you get to the body and it's like X colon colon A, what the hell is that? I don't know what that is. The scope type variable just extends the scope of the A.
Oh, yeah, yeah.
So you could
I
So
refer
now
to
when you say A down here, it knows you're referring to the A up there.
I've
Yeah.
I've needed this for code where it complained, and I needed a way to refer to a type
Yeah, what
variable,
happened-
but I didn't
yeah.
have a way to do that
Yeah, yeah, yeah.
polymorphically. Because
So
if it was only
this
going to
comes
be
up-
concrete, then it
Yeah.
wouldn't matter.
For me, this has come up when I have a longer function body and I've got a where clause and I've got helper functions that I'm defining inside, and I want them to refer to some type variables in my topmost function,
Yeah.
and then it's handy. Yeah.
Well, I mean, without this, do you have to put a type annotation on XS saying it's a list of A? And then
No, it won't work.
No, because
Well,
it
still
still won't know what the
Type
A
variables
is.
don't
Right? It'll be
exist
like, "Hey, I
outside
don't
of
know."
type signatures, period.
Oh,
Yeah.
so it stops right at the double colon.
Yeah,
Oh,
exactly. That's what this allows. Is it,
Okay.
it introduces them into a scope for everything else.
Got it.
That's a good question. You should not ask me because I'm the worst person to ask. No, I'm an okay person to ask, but direct. So your question. What's your name?
My name's Nick. So these are like the good extensions. I mean, they seem practical. I don't know.
I don't
There are a
know.
lot of good in
Are there bad extensions? I guess. Are there?
There's more controversial extensions,
Yeah,
but
there's
not
there's
necessarily.
like the most dangerous extensions, even Oleg can find a use for them. That seems legit. So like, it's really hard to argue against any one extension because really, if it was a truly bad idea, again,
Oh,
Some
no,
pretty
no,
conservative
so-
compiler
so-
team.
the
Like,
time pass
incoherent
ones.
instances
Yeah.
or like overlapping instances, like
overlapping is not even the worst
If
one.
you-
Undecidable
If
instances.
sound-
Yeah,
there you go. That's a good
yeah.
None of the ones listed here. have
Undecidable
that
instances.
I think that's pretty like safe.
Hopefully I don't have any of those in my code. Well, I guess it doesn't matter, I
If
work here
you
anymore.
read a cross extension and you
They're worth
see
maintaining my
like
Haskell code
Simon
bases.
Peyton Jones looks like he's wavering on his opinion of this, like, you know, like, just like, you know, like, this is breaking too much stuff. Use carefully, you know.
Yeah.
Like, you'll see that kind of disclaimer on a handful of extensions.
Okay. These are like the common ones, though. Like,
Oh, God, that's hard.
That's hard, too.
You're not gonna run into the dangerous ones unless you're following along with like Oleg's tutorial or something, and then like your compiler's gonna be like, you sure?
But Oleg almost always provides desugaring too.
I really think that anytime, and I'm gonna say something, I think it'll apply pretty broadly. Anytime you find yourself reaching for an extension, go ahead and ask yourself, how would I do this otherwise? And is that better? Like, you know, like, like, in fact, some of the questions I've been trying to ask have been like, at least like, quasi in that spirit. So, I'd recommend anyone to do that, because it's possible to go a little crazy with fancy techniques, and then completely forget that, like, you may not really need something like that. So existentials, occasionally you'll feel people say, like, look, it's not that existentials are bad, it's just that you don't need them in, like, all these places that you've been using them. Like, there's just an easier, more sane, like, simpler approach. Okay.
The honest answer to these extensions being chosen are, one, they were the ones that I felt more comfortable about being able to talk to. They're the ones that I was most interested in at the moment. And
Did you use the blog post, Oliver's blog post, to guide your decision?
a little bit. Like, I think I wanted to talk about static pointers, but then I ran out of time because I honestly started writing these slides this morning.
Okay.
Yeah.
Great job.
Yeah, it was great.
Beamer, everything.
Pandoc did it all for me. That's all marked down under the covers.
No, I got you,
Nice.
I got you.
Yeah.
I got you.
Another thing I wanted to note on that is that the remaining extensions are largely for kind of approaching dependent type techniques. Like if you start getting into data kinds, kind promotions, type literals, type families, role annotations. I would like to present all of those in a single chunk because they are so heavily interrelated. These kind of can stand alone a little bit on their own. Most of them do. Mm-hmm. Yeah. So, scope type variables, one really frequent use that I used when I was doing web space stuff, still am doing web space stuff really, is just when doing exception handling, like try some HTTP request on this URI, catch some exception, which is at the very top of the exception hierarchy, so all exceptions. And this is our exception handler for E. And all it does is just print oh no, which is the greatest logging solution I've come up with to date. So yeah.
You need to know.
Yeah. Dangerous combinations I didn't get to fill in, but there's a good blog post here about what happens in older iterations when you combine GND and GADTs and then something else. Unsafe course. Bam. 2 different ways to make it.
Like a genuine bug.
Yeah, it was a bug.
Mm-hmm.
But there are, I mean, the dangerous combinations that aren't bugs generally involve jiggering around what you're allowed to express in type class instances, like undecidable and overlapping. And I think there's actually one worse than undecidable. I can't remember.
I don't
Well,
know. Actually,
incoherence among up there. I don't think it's as bad as undecidable.
It sounds bad. Incoherent.
No, I think incoherent might be one of the harder
I was
ones.
like, Scala.
Oh, shit.
We made it to the end. Next steps, check out the user guide, play with some extensions, resources, check out the GHC user guide. It's fantastic.
It's a pretty good read, actually. Like, the GHC user guide. I know that sounds tremendously geeky, but it's actually a very entertaining read. I don't know.
It really is.
That's like
good.
getting to the bar.
Yeah,
Like, that's
yeah.
like
That's good.
informative.
Good.
Like, I would
They're
stop
nice
there.
Good examples, and it's good. It's conversational, and
Okay,
like,
excellent.
You get to the functional dependencies section in type classes, and there's an actual comment in there that says, we know this isn't very well documented, yell at us.
All right. Thanks for your
Yep.
time.
Yeah.